Okay, we're starting topic 1-2, areas of regular polygons. Now, there's a word on here that's kind of important, the word regular. Regular means all the sides of the polygons are the same and all the angles are the same. So, you might want to remember that. Let's write that up here under this word, regular polygons. I'm going to write it up here. That's what the word regular means. So regular polygons are equiangular that just means all the angles are the same, and equilateral, that means all the sides are the same. Okay. Make sure you remember that. It doesn't have to be a triangle. We're just going to start with a triangle. We'll talk about, I'll show you my template here, all the regular polygons on this one. Now the circle's not a polygon, but that's a regular hexagon. This is a regular triangle. This one's a regular quadrilateral, and this one's a regular pentagon. So regular just means they are all the same side and all the angles are the same. Now in this picture we're going to label the things that are pointing to. This first one up here on the left is called a side. This line that connects the center to a vertex is called a radius. This point in the middle of your regular polygon is called the center. And then this dotted line right here has an interesting word. It's called an apothem. A-P-O-T-H-E-M. Pronounced apothem, and that's an important one because you're going to use that when you do the area formula. You're going to have to figure out the apothem each time and the perimeter. If you'll look at the formula here in the shaded part, it says 1/2 the perimeter times the apothem. That's what you're going to have to do to figure out the area of a regular polygon. So look at example 1. They've drawn a triangle. They told you that it was regular. That means even though they've only labeled this side 12 centimeters, they're all going to be 12 centimeters. Now on this one, they've actually already given you everything you need because this right here is the apothem. I'm going to write that on here. That is the apothem. So all we're going to need to really do right now is figure out the perimeter. And the perimeter of these triangles, you're always going to just multiply 3 times whatever the side is. So since the side is 12, you're going to multiply 3 times 12. So your perimeter in this case would be 36 centimeters. Go ahead and write that on P equals. That just means the perimeter. Now let's use the new formula we just learned. It's 1/2 the perimeter times the apothem. I'm going to go ahead and write that out. It's 36 times 2 times the square root of 3. Now I'm going to remember we're going to leave in radical form. Most of the time I will do that. If you end up giving an answer in decimal form and it's equivalent to the radical form, I probably won't count that wrong, but I do want you to learn that when you have a multiplying by the square root of 3, you just need to leave it as a radical. So you're going to multiply 1/2 times 36 times 2 and then leave this as a symbol. So that's 36 times the square root of 3. And you can leave your answer 36 times the square root of 3. You just write a radical 3, and then since it's area, it's a square unit, so put centimeters squared. Now I did go ahead and put this in the calculator to figure out what it would be, and it is 62.4 approximately. So if you want to write the decimal form, you may. You can do that. Alright, example 2 says find the indicated measures of this equilateral triangle. Now this time it's interesting, we only have a side. It's only giving us the side length. So you will have to figure out the apothem. Let's talk a minute about the characteristics of this triangle. All 3 angles are 60-degree angles. I'm going to go ahead and label those. Now this one I'm going to wait to label it because I want you to notice the radius right here does divide the 60-degree angle into 2 30-degree angles. And since you already have a 90-degree angle here, you do have a special right triangle, a 30, 60, 90 triangle. And when you draw the apothem, it does bisect the side. So if 18 is the length of this side, 18 is the length of this side is also 18. That means half of 18, which is 9, tells me the length of the side opposite the 60-degree angle. Now, let's kind of review for a minute. I'm going to draw a special right triangle up here, and I'm going to label it 30, 60, 90. Remember to name it as the short leg is x, the long leg is x times the square root of 3, and the hypotenuse is 2x. Okay. So on this one, our x times the square root of 3 happens to be 9. So I'm gonna show you this little formula. X times the square root of 3 is the length opposite the 60-degree angle, so it is, the value is 9 in this case. Now to solve this one for, in our case, the apothem, to get the short leg, you're going to have to divide by the square root of 3. Now you can put that in the calculator if you want to, but it's going to give you a decimal. So I'm going to show you how to keep this in radical form, and it's a review. It's called Rationalizing the Denominator. And what you have to do is you have to multiply both the numerator and the denominator by the square root of 3. And this is called rationalizing the denominator. There's a rule in math that you cannot leave a radical in the denominator, and the square root of 9 is what you would get in this denominator would be just 3. That's called a perfect square root. So 9 times the square root of 3 is going to be divided by 3. Now when your coefficient is 9 and you're dividing by 3, you can divide 9 by 3. To simplify this further, you'll get 3 times the square root of 3. Now again, if you were to put that in and do it as a decimal, you would get a different answer, but it would be the same meaning as 3 times the square root of 3. But this is the apothem on this one, 3 times the square root of 3. The perimeter, remember, is adding the 3 sides, so 3 times 18, which is going to give us 54 meters. Our apothem is 3 times the square root of 3. Or if you happen to put that in the calculator, this would be about 5.2, so I would accept the decimal form if you want to do that, but for our notes we're going to leave them in radical form. Now let's rewrite the formula for a minute so you'll remember it's 1/2 the perimeter times the apothem. So it's going to be 1/2 times 54 times 3 times the square root of 3. I think I'll show this one. We'll just do it in the calculator. I'm going to type it in. Move this over so you can see. And I am going to leave the square root of 3 as a radical. I'm going to leave that alone. So it's 1/2 times 54 times 3. So the answer, if you're leaving it in radical form, is going to be 81 times the square root of 3. Let's go ahead and see what that is as a decimal. So if you were to put it in as a decimal, it would be about 140.3. So let's leave it as a radical. So it's 81 times the square root of 3. Now the apothem is just a measurement of meters, but an area is a square meter. So when you label your answer, you do need to put the square unit for area and just the unit when you're doing just a length. Okay, let's move on to example 3. Here's another regular triangle, and this time they're giving us this 8 times the square root of 3 inches does represent the radius of the triangle. So it's the hypotenuse of a 30, 60, 90. And remember, to get the short leg, you always take this one. This represents twice the short leg. So if we label this one x, 2x would equal 8 times the square root of 3. Now to solve for the x, which is our apothem, you're going to divide both sides by 2. That gives you x equals, and again here you just divide this coefficient by 2, so that's 4 times the square root of 3. Let's go ahead and write that for a, because that is our apothem. Now to get the perimeter, we're going to have to figure out our long leg and then double it. So remember, the long leg is whatever your short leg is times the square root of 3. So since we have 4 times the square root of 3, let me show you what's going to happen. If you multiply 4 times the square root of 3, your short leg, times the square root of 3, anytime you multiply square root of 3 times square root of 3, that's going to be the square root of 9. If you notice, that's a perfect square. So this is really 4 times 3. So this is going to give me 12. And this is going to be my, I'm going to write over here that this is my side. Actually, it's half of the side. 12 is half the side length because 12 is what I got when I multiplied my short leg times the square root of 3. So what do you think this is going to be? That's right, you're going to double it. So the entire length of your side on this, in this case, would be 24. Now remember, the formula for a regular polygon is 1/2 the perimeter times the apothem, so it's going to be 1/2. Now the perimeter on this one, you're going to have to do 24 times 3. That's going to give you 72. Let's go ahead and write that here. So 72 is your perimeter, and now your apothem is 4 times the square root of 3. And again, we're going to leave it in radical form, so you're just going to type in, when you punch it in the calculator, just type in the 72 times the 4 and then leave the square root of 3 alone. Just leave it as a radical. So really what you're doing is just this part right here. So that's going to be what you multiply. Let's punch that in. See if I'm doing this right. So it's 1/2 times 72 times 4. So that's 144 times the square root of 3. That's going to be the area of this one. Let's go ahead and put that one in our calculator and see what it is as a decimal. If you type in 144 times the square root of 3, your answer is approximately 249.4. And you can write it in decimal form if you choose to. I'm going to keep it in radical form. Remember, it's square inches when you're doing area, and then the other two are just inches, because those are just lengths. Perimeter is just a length, and so is this apothem. Let me know if you have trouble with that one. That one's a little bit trickier. I can help you with those. Okay, let's try example 4. On example 4, I think I'm going to use my template here and draw a little triangle. If you want to borrow one, I have plenty of these templates. You can use one to, anytime you're working with notes and you want to write down or use the template for some of your pictures, you can do that. Okay, this one we're going to have to find the area. We're still going to have to use the same simple formula of 1/2 perimeter times apothem, but on this one they've given us the perimeter, so that's kind of half the battle here. Perimeter times the apothem, we already know that the perimeter is 24 times the square root of 3. So we have to figure out what the apothem is. I'm going to kind of write that out over here. Let's draw a picture. It's going to look like examples 2 and 3. I'm going to put a center point, draw a little dotted line for the apothem, and then draw your radius. And again, just keep remembering that this does create a 30, 60, 90 right triangle. Okay. On this one, since they gave us the apothem, they gave us the perimeter. If 24 times the square root of 3 is the entire length of this side, half of that means that this is 12 times the square root of 3. That means from this part just to here, because half of 24 is 12. So that's how you know the part right here. Okay, if this is, wait a minute, I didn't do that right. Oops, the perimeter is, I'm sorry, I need to back up. The perimeter is 24 times the square root of 3. So if we divide 24 by 3, that means each side is 8 times the square root of 3. So half of 8 is 4. I apologize. That's going to be 4 times the square root of 3. So if 4 times the square root of 3 is half of this side length, and that's the long leg, that means your short leg is going to be a 4. because the short leg is always, if you know the long leg times the square root of 3, that's going to give you the short leg. So there it is. Our apothem on this one is a 4. So punch this in your calculator. 1/2 times 24 times the square root of 3 times 4. And if you want to leave it in radical form, you will need to just leave the radical 3. So half of 24, that's 12, and then 12 times 4. Let's make sure I did this right. Yes, that's 48. So 48 times the square root of 3, and this is square centimeters. That would be your area for example 4. Okay, one more page. Example 5. Again, there's not a picture, so if you want to sketch one or borrow the template to draw one, draw an equilateral triangle. I think I'll go ahead and put it for example 6 also. Alright, this one on example 5 says a regular triangle has an apothem with a length 2, and they want you to find the area. So let's draw it again. Our center point, our radius, the dotted line. The dotted line is the apothem, so that's 2. 30, 60, 90 triangle means that this is going to be 2 times the square root of 3. If we take that and double it, because your side length is always going to be bisected by the apothem, so 2 times the square root of 3, if you double, makes this 4 times the square root of 3. I think I'm going to go ahead and label all all 3 sides. So 4 times the square root of 3 is the length of each side. And when you multiply that times 3, that means your perimeter in this case would be 12 times the square root of 3, because there's 3 4s. We're ready to use our formula. It's 1/2 the perimeter times the apothem. The perimeter is 12 times the square root of 3, and the apothem in this case is 2. I'm going to leave it in radical form, so 1/2 times 12 is 6, 6 times 2 is 12, so 12 times the square root of 3 is your answer. That wasn't as hard as you thought it might be. I hope. Let me know if you need some more help. Okay, let's try one more. And remember, you can always pause and back up and re-listen to the video if you're having a little bit trouble understanding. I think maybe sometimes I go a little bit too fast, so you probably can't slow me down, but you can pause it. Okay, again, draw your center point, your apothem, and your radius. This one gives you the radius, so the radius is 10. This one is the hypotenuse of a 30, 60, 90, so when you take half of that you get 5. So if you notice, there's the apothem. If you want the long leg of a 30, 60, 90 triangle, it's always the short leg times the square root of 3. So that's going to give us this piece right here. Now when you double that, that's going to give you 10 times the square root of 3 when you double your 5. So let's do like we did on example 5 and go ahead and label. 10 times the square root of 3 is going to be your side length for all 3 sides. So your perimeter here, since it's 10 times the square root of 3 3 times, that's going to be 30 times the square root of 3. And then your apothem was 5. So here we're ready to use our formula. It's 1/2 the perimeter times the apothem. The perimeter is 30 times the square root of 3, and the apothem is 5. Let's leave it in radical form. It's really kind of easier just to leave it in radical form. So you're just going to multiply 1/2 times 30, which is 15, 15 times 5, which is 75, so 75 times the square root of 3. If you want to put it in the calculator, remember I'm okay with that. If you want to put the decimal answer, it's approximately 129.9. And always remember to label your area problems with square units. So since this one says inches, the answer is 75 times the square root of 3 square inches. Okay, we're through with section or topic 1-2. Let me know if you have any questions.